Hey guys, so we started talking about related rates problems. Now let's talk about starting a problem and solving it from scratch. So, patience is key, as well as modeling. So the problem reads a pebble is dropped in a calm pond, causing ripples in the form of concentric circles, as shown in figure 2.34. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area of the disturbed water changing? Hmm. So we have to take into account all the information provided for us. And so the first thing is I know they're talking about circles, so I'm going to jot down a couple equations that may or may not help. I know that C is equal to 2 pi r, and I know that A is equal to pi r squared. Right? These are the equations for circles that we know to be true. So we got to think about, well, which one would make the most sense to use in this situation, if it's even one of these. So reading through this, what pops out to me is this. I got a fancy highlighter. At what rate is the total area of the disturbed water changing? So the reason why I mentioned that is I'm dealing with area, so I know that I don't really need this equation when dealing with circumference because we're talking about area. Okay. But let's talk about what else they tell me and what does that mean. So here's another thing. The radius of the outer ripple is increasing at a constant rate of 1 foot per second. The radius of the outer ripple is increasing at a constant rate of 1 foot per second. So, don't freak out. dr dt is equal to 1 foot per second. The change in radius, change in time. And I got that from the units, and I use r because they're talking about the radius r there. Okay? So, once I have that, I need to figure out where is that dr dt going to come from, and what is that question really asking? So that question is talking about the area of the disturbed water changing. So I know they're talking about dA, but what is it changing with respect to? Well, it's changing with respect to time. So I'm looking for dA dt, and I'm trying to figure out what is that value going to equal in this problem. So if you look at the equation we have for the area of a circle, I see the r and I see the a. I see the r and I see the a. So the reason I underline those is so you can kind of make sense of what's going on here. I'm going to take the derivative of this equation with respect to time, right? Because here's what's going to happen from here. When I take the derivative with respect to time, d of d dt of a will give me a dA dt. And taking the derivative of the other side, all right, well, it's pi, but pi is a constant. So I'm really just focusing on taking the derivative of the radius squared, which should give me pi times 2r dr dt.